Hi, this is Jeff Heaton. Welcome to Applications of Deep Learning with Washington University. This is Module 5, Classification and Regression. Part 3, Regression. For regression, we're going to look at the miles per gallon data set that we saw before. This will be a frequent example, through the early part of this class anyway, of a regression problem. We're taking a car and attempting to predict what its miles per gallon will be based on other statistics that we have on that car. So we will load this pretty much exactly like we did before, loading it from the miles per gallon data set. And we will fit a neural network to it. We will use early stopping. We will make sure that we grab the best neural network from the time up to the point that it early stops. We will print out the root mean square error, but we will also plot a lift curve for regression. Okay, I'm running it now, and it's training the network, and will be done in a moment. By the way, you can tell that this is a regression network because we have the single output neuron, and we're measuring it with the mean square error and reporting it as root mean square. Okay, now this is actually a pretty bad train. So you'll see this sometimes with in your own neural networks. This basically means that the auto MPG neural network basically just reported the same value for every single one. If you're not really giving it enough neurons to actually train with, this can happen. Usually you just want to bump up the size of the neural network. Okay, that's a much better one. You can see it's somewhat noisy, and that it's bouncing around. The kind of tan color is the prediction. The blue is the expected. So as we increase the real miles per gallon, the blue, we can see that the predictions are going pretty close, but you can definitely see the noise where it's bouncing above and below the line that you're trying to predict. Now this is a lift chart, so it's important to understand how to read it, because that may not be obvious from the beginning. The x-axis, that simply goes to 100 usually. That's the percentage of the data that you've been through. It's really, the x-axis is not all that useful on this one. The y-axis, this is the actual value. So that's 10 miles per gallon, 15, up to 45 miles per gallon. So that's the value that you're actually trying to predict. The way that this works, and to generate a lift chart, this is really what you do. You sort the data by expected output, so the y. And for every point on the x-axis, plot the predicted value of the same point. So that's why this is consistently increasing, sometimes said to be monotonically increasing, is we basically took all of the cars and sorted them by the miles per gallon, which is what we're trying to predict. And it starts from very small all the way up to very large. We do the same thing with the predictions, although we just keep the predictions lined up to the expected values, so that basically we take the expected values and slowly increase them, and then we just plot every single corresponding actual prediction to line up with the expected values. The jaggedness that you see is definitely noise in this data set, which is somewhat unavoidable with at least without some other measures. But this is a relatively noisy data set in that regard. But we still got a pretty good root mean square of 3. So it's plus or minus 3 3 values, or 3 miles per gallon values. So how to read it? The expected should be close, and they're reasonably close. And you can see that it tends to be, I don't know that I would agree with that. It's from different runs. It can be a little bit different. I would say from this one, it is, it does seem to be, it seems to be the most accurate actually on the higher, and then it kind of deviates off a little bit here. Whereas in the lower, it's bouncing around quite a bit. But that's just a pure observation. Now to see how this is actually executed, we go back up to the code, the new code that I had given you. Yeah, chart regression. So we've got to accomplish that sort. And sort is usually true. You could tell it not to sort. If you don't sort, you get an entirely different view of this data altogether, which is so if you don't sort, we'll get another one. Oh, sort. So this is a little bit more interesting. It can be a little more interesting. This is showing you basically the data in the order that the data came in. So you can see very much that it's the predicted is follow, or the expected, the predicted is following the expected. This is exactly the same view, it's just more sorted. So this, at first glance, may look a little bit more accurate, but on some of these points, the swing is pretty high. So that's resulting in here and here, probably. But that's just showing what it looks like unsorted. But if we are to produce the output, we do need to sort it, because producing the output, which we do up here, we create a data frame with the prediction and the y. So we're going to have the predicted values and the actual values literally side by side. Then we are going to sort it. If we requested a sort, we will provide a sort. We sort in place for greater efficiency, and we're sorting by y. So we're sorting by the expected outcome. And then we're going to plot it. We need to provide, since this is a line chart, we need to provide the two axes that we're plotting against each other. That's y and pred. And we're going to label the y-output, the y-axis as output. And we'll show the legend for it and plot it. And that basically gives you the two charts that you see down here. So I gave you really 4 charts that you can actually look at. You have the 2x2 confusion matrix. That is used when you have binary classification. You have the n by n confusion matrix. That is used when you're working with multi-class classification. You also have the rock chart, which can be used for binary classification. And you have the lift chart, which you see here, which is used for regression plotting. It's important to know which chart you're going to use for which type of data, whether you're doing classification or regression, somewhat guides that. And then also how many classes you have. If you're dealing with just binary classes, you have some additional options because you can use the ROC chart. All right, that is the end of this module.